Yeah, good afternoon, everyone. My name is Adeyemi Adekule. So I want to continue with the class that we had last time, and I will just try to do a kind of recap for us on what we did last time. So I said I will be dealing with differential calculus, and I started with the elementary part of it, where I said that y equals ax raised to power n. If we look for the dy dx, you can see that our dy dx equals. Then this n will come here, making a times n, then x raised to power n minus 1. For instance, if y is given to you 4x raised to power 3, like I said it's going to be, your dy dx now will be the 4 times 3, which is 12, then x raised to power 3 minus 1, and that will be 12x raised to power 2. So that's what we did basically last class. So I will be continuing with that today, and I will be dealing with standard derivatives. I'll be dealing with standard derivatives, and by God's grace, I will be showing us how to get how the standard derivative are we getting. Yeah, so the very first one that we have, yes, is y equals sine x, and your dy dx of sine x is equals to cos x. This can be proven by first principle. Then if y is equals to cos x, our dy dx also can be equals to minus sine x. Minus sine x can be equals to minus sine x. Another thing that I want us to take note of is that anytime you hear the word dy dx, it can also be represented as y prime. That is first derivative. If it is y prime prime, it means the squared y over the x squared. That's the second derivative. You are different for this now, you are differentiating twice. But for this, you are just differentiating once. Are we still together? Then again, if y is equals to coming, all right. So if our y also equals tan x, what will be our dy dx? Like I said, that can also be proven with first principle, or you use the approach of quotient rule. But we are going there very soon. So if y is equals to tan x, at the same time, our dy over dx will be equals to sec square x. In some other textbook, they can write it as sec x all squared. And sec square x or sec x all squared is the same thing as 1 plus tan square x. This is a trigonometry function. Let's take note of that. So I've given us three things. Number one, if we differentiate sine x, it's going to be equals to cos x. If we differentiate cos x, it's going to be equals to minus sine x. And if we differentiate tan x, it's going to give you sec square x, or 1 plus tan square x. All right. So moving on, there is another standard derivative that we must know. That if our y is equals to e raised to power x, then dy over dx is also the same thing as e raised to power x. Meaning that for this, I can say that my y prime, which I already told you that is the same thing as dy over dx, which is equals to e raised to power x. Now, if you notice, e raised to power x is the actual question that we have. So we can still say that y prime is equals to y. Why? Because our y prime and our dy dx, they have the same answer. So anytime you differentiate exponent of x, the answer is always equals to exponent of x. I believe we are following me. I believe we are following me. Well, this can be proven. Let me try to prove it for us. If y is equals to e raised to power x, you can add log base c to both sides. Log base e to both sides. Meaning that log y base e is equals to log e raised to power x base e. Now, have this at the back of your mind, that if you differentiate ln x, let me quickly rush through that for us. If y is equals to ln x is the same thing as log x base e. the answer, our dy dx at this point in time is going to be 1 over x. Please, let's take note of that. Anytime I differentiate ln x, my answer is always 1 over x. So here now we can do some mathematical approach. We can have some mathematical approach to this by saying this can be written as log, like I said, log y base e also can be written as ln, right? So I can say ln y equals, now let's use logarithm here. This x that we have can come to the back, right? According to logarithm. So which means I can say x log e base e. And what is log e base e? Log e base e fundamentally is 1. When the logarithm and the base are the same, the answer is always 1. Just like you have log a base a, it will be 1. Log 10 base 10, it will be 1, right? So from here now, we can say ln y is equals to x. I believe we are following me because our log e base e has already turned to 1, right? All right. So please, I want us to be following me very closely. All right. All right. So from here now, if we should differentiate ln y, it's just like you are differentiating ln x. When we differentiated ln x, we have 1 over x, right? So if you should differentiate ln y, we are going to have 1 over y. But because we are differentiating the independent variable, like I said, sorry, you are differentiating the dependent variable, like I said, so you have to include your dy dx. Meaning, anytime you are differentiating y, you add dy dx to it. Now, equals, what I'm trying to do here is I'm trying to differentiate both sides. I'm trying to differentiate ln y and I'm trying to differentiate x. Are we still together? You differentiate both sides, it gives you 1 over y dy dx for the first part. I mean the left-hand side. The right-hand side, which is our x. If you should differentiate x according to what I taught you, the first rule, if you differentiate x, that should be 1. Right? Okay. All right. So taking y to the other side here, sorry, taking this y to the other side here, it means I can say that my dy dx is equals to 1 times y. 1 times y. Then dy over dx can be equals to y. Now let's replace it. What is our y itself? If you remember, the initial question is y equals e raised to power x. That's the initial question. Y equals e raised to power x. So instead of using the ordinary y that we have here, we can replace it with e raised to power x. That's why the derivative of e raised to power x is also the same as e raised to power x. The derivative of e raised to power x is the same as e raised to power x. So I've given us 14. The first one, differentiate sin x, you have cos x. Differentiate cos x, you have minus sin x. Differentiate tan x, you have sec square x, or 1 plus tan square x. Now, differentiate e raised to power x, you have e raised to power x. Differentiate ln x. Now, if you differentiate in x, like I said, is equals to 1 over x. All right. So let's move further with something that is kind of a little bit advanced. So I will be using the rudiments, the knowledge that we have at the rudimentary level to attend to others. All right. So there is another one. If you have y equals log, let's say log x base a. Now the base is not e. Assuming it's base of e, we will say the answer is 1 over x. Are we together? We say the answer is 1 over x, assuming we have a base of e. But now the base that we have here is base a. How do we attend to that? All right. So according to law of indices and law of logarithm, we have what we call change of base. So we can attend to this using change of base. Or you can use a reverse case of indices and logarithm. What do I mean by that? This a can come to the other side here, and this x remaining. What I mean by that is, sorry, what I mean by that is I can write this particular question as a raised to power y equals x. So I'm using the approach of changing logarithm to indices. So y equals log x base a also can be written as a raised to power y equals x. Now, instead of differentiating with respect to x, let's try to differentiate with respect to y. Are we still together? Instead of differentiating with respect to x, now let's try to differentiate with respect to y. What do I mean by that? Let's look for dx over dy. Now, you notice that since we'll be looking at dy over dx, but at this point in time, I want us to look at dx over dy. Now, how do we solve this? I can write this as x equals a raised to power y. Now, let's try to add ln to both sides. What I mean by adding ln to both sides means adding log base e to both sides. Like I already told us, log base e is the same thing as ln. All right, so adding ln to both sides, we can have ln x equals ln a raised to power y. Now, ln is also logarithm because it means log base e. So this particular y that we have here, we can take it to the other side. But don't forget, we are differentiating with respect to what? To y now. All right, so from here, we can have ln x equals y ln a equals y ln a. Even if you like, from here, you can even try to differentiate with respect to x. It doesn't matter. But I feel maybe we should just differentiate with respect to y. Then at the end of the day, we reciprocate. But we can still differentiate with respect to y here, since it is direct. Now, what do I have to do here? I have to differentiate both sides. Now, don't forget, anytime we differentiate ln x, we always have what? 1 over x equals y ln a. The ln a that you have is just acting like a constant. We call it arbitrary constant. It's acting like a constant. So the only thing that we need to differentiate here is our y. Now, if we differentiate y, that is 1. But don't forget, anytime you differentiate y, like I said, you must always add dy dx. So y 1 dy dx, then we are left with a constant, which is ln a, which means I can write this as 1 over x equals ln a dy over dx. So, and what we need basically in this is our dy dx. So, meaning I can make dy dx the Sawyer formula by saying my dy dx equals 1 over x ln a. Our dy dx equals 1 over x ln a. Our dy dx equals 1 over x ln a. So meaning the derivative of this is dy over dx, like I said, is a standard derivative. Dy over dx equals 1 over x ln a. In some another textbook, we can see it as 1 over x log a base e. In, in another textbook, you can even see your answer as 1 over x times 1 over log ABC can also be written as log E base A. So meaning that this particular question has two answers in quotes. I can say my dy dx, like I told you, dy dx is the same thing as saying y prime, right? Dy dx means y prime. That is the first derivative, the first derivative, the first derivative, the first derivative. So I can say that from here, my dy dx is 1 over x ln a, or you say is 1 over x log a base e, or you say that is also the same as log e base a over x. I believe we are following me. I believe we are following me. So I've given us close to 6 standard derivatives and how they are being gotten. All right, so the next thing I want us to look at is when we have y to be equals to a raised to power x. When we have y equals e raised to power x, we already know that the answer is e raised to power x. Now, what if we now have our base as a and not e? Let's quickly rush through that as well. All right. All right. Good. I believe we are still together. Y equals a raised to power x. How do we tackle this? It's still the same approach. You add ln to both sides, meaning I can say ln y equals ln a raised to power x. X coming to the back, according to law of logarithm, I can say x ln a. So what else can we do? You differentiate both sides. But don't forget, anytime you differentiate to y, you add dy dx. Anytime you differentiate y, you add dy dx. Differentiate in y. Just remember, when we differentiated in x, the answer that we got was 1 over x. So if you differentiate in y, your answer also will be 1 over y. But at this point, you will be adding dy dx. So from here, differentiating in y, I can write it as 1 over y, but what? Dy dx must be added, equals differentiate x, that is 1. Then you keep your constant. Our constant is ln a. Like I said, is an arbitrary constant. No need of differentiating that. You just add it. All right. So from here now, we can say that our dy over dx can be equals to this y. We have to go to the other side here. So we can say y into ln a. But we don't want to say anything related to y in our answer. We'll replace it. What is y? Y itself is a raised to power x. So instead of writing this particular y, we can write it as a raised to power x ln a. What am I trying to say? If you are giving y to be equals to 2 raised to power x, automatically your y should be equals to 2 raised to power x ln 2. And don't forget, ln 2 is also the same as what? Log 2 base e. Log 2 base e. All right, I believe we are still together. The last one that we'll be doing for us today is this. I've been seeing a lot of questions related to this. That if we are given y equals x raised to power x, y equals x raised to power x, how do we differentiate that? We still follow the same idea. Add ln to both sides, meaning I can say ln y equals ln x raised to power x. According to law of logarithm, the x we have to come back. Then we say ln y equals x ln x. Differentiate both sides like the way we've been doing. If we should differentiate ln y, we have 1 over y, but we had what? Dy dx. Now, looking at this, we have x ln x. X ln x is different from x ln a. Ln a is an arbitrary constant, so we are not touching it. We are just keeping it as a constant. But for this, we have ln x. We can't say ln x is an arbitrary constant because we have one independent variable there. We have x itself acting as the independent variable, and we also have ln x, where we also have our x acting as the independent variable. So what do we have to do here? We call something product rule. I've not gotten there for us, but I will just give us the scope on how to do this. Follow me very closely. The scope under this is you have to differentiate the first one. Your first one is your x, then you take ln x as the second. Differentiate the first one, which is x. Differentiate x, that's 1. Keep the second one, that's ln x. When I say keep, I mean you rewrite. Are we together? Keep the second one, that's ln x, plus keep the first one, meaning that you rewrite x. Are we still together? Then differentiate the second one. That is, you differentiate ln x. And according to what we've been doing, if you differentiate ln x, the answer should be 1 over x. So meaning we have 1 over y dy dx equals to ln x plus x times 1 over x is x over x. Automatically, x over x will cancel each other. Then we have 1 left, right? So 1 over y dy dx can be written as ln x plus 1. Taking y to the other side, like we normally do, we can say that our dy dx equals y into bracket of ln x plus 1 plus 1. Now, what is our y? We have to repeat it. What is our y? Recall, y equals x raised to power x. So I can write this as x raised to power x into ln x plus 1. If you like, you can open the brackets by saying x raised to power x ln x plus 1. Or you say x raised to power x. What is ln itself? Ln means log base e. So x raised to power x log base e of x plus 1. Thank you so much. Like the video, subscribe, and do well to share. Thank you. God bless you.